For question 4, you'll see part A is based on the vectors A and B that are given, but part B are they're different vectors completely, so you just treat them completely separately from part A. And we have a statement that says that the first coordinate of our resulting vector is -3. And if I were to just kind of go through each of the steps, that came from this value here, and the product of these values here. So I could write out an equation just for that. It would be 2 plus a minus 6 equals -3. And for that, I can rearrange and isolate a and solve for a. So -3 minus 2 plus 6, a equals -5 plus 6, a equals 1. Then I would do the same thing, but for the second vector coordinate. And now I have that -1 plus b minus 3a will equal 1. And I already know that a equals 1, so I can substitute that in. And by isolating for b this time, we have 1 plus 3, b equals 5. And lastly, for the third coordinate, we have c, 1, 4, and this 2c. We have the equation that c plus 1 minus 3 times 4, we'll distribute that, just like we did for the other one, equals 2c. And collect like terms, all the c's on the same side, so we have 2c minus c, and 1 minus 12, so c equals -11. There you go. A equals 1, b equals 5, and c equals -11. So this one's very straightforward. Just treat each component separately. The x component, the y component, and the z component.